what I'll try to do the first part. And then we'll come to the switch 1, switch 2, and switch 3. Especially on the switch 1 and switch 2 and switch 3, we'll get into the VLAN configurations. We'll try to configure the trunk links. And also we'll try to assign the ports on the VLAN, like the switch 3 port in the VLAN 10, VLAN 20, VLAN 30, VLAN 40. I'm going to use 4 different VLANs for verifications. So I'll be creating VLAN 10, 20, 30, 40. And the links connecting between the switches will be configured as a trunk. And of course, we'll also assign the IP addresses. That I'll keep it as a third part. So on the same switches, we'll assign the IP address as well as we'll assign the default route pointing towards the ISP. And the fourth thing, will also configure the NAT with using exit interface. Hopefully, this is what the only thing we have to do. In case if I missed out, I will try to see. So we'll go one by one. So we'll start with the devices. I hope the devices are already started. I'll start with the router 1, router 2 here. So let's go to the router 2. On the router 2, as it's a new device, it doesn't have any configurations. So the blank configurations will simply skip the setup mode with a no command. And we'll try to do the initial configurations first on the router. Okay, so let's start with that. So on the router side, we need to assign the IP addresses. And if you see the topology, I'm using G0 by 1 interface, which is connecting towards the other side. I'm using 1.1.1.2. You can use any subnet. Typically, I try to use the same subnet what I used in my previous labs, but it can be anything. On the G0 by 2 interface, it's going to be 2.2.2.1. Assume these are the public IPs which are present. Interface G0 by 2. No shutdown command to make the interface up. Okay. So this is on the router 2. The host name will change to router 2, which is acting as my ISP. Okay. And make sure that you save the configurations as well. And additionally, what I'll be doing is I'm going to create some loopback interfaces, which will be simulating my internet routes. So I'm going to create some loopback 0 12.0.0.1 with slash 32 or 24, whatever you want. I'm just creating 2 loopback interfaces. That's enough for testing. Even one will be good enough for testing out. Okay. So make sure that you save the configuration, and this is the only configurations what I require. And in case if I need any additional configurations, we'll see later on. Okay. As of now, we'll stick the configurations and make sure that we are exporting so that the next time when I load the configurations, it has to load with these initial configurations where I don't want to do again and again. Okay. Now that's the first part. Now moving on to the switch, the second step, we'll go to the switch 1, 2, 3, where we'll try to create the VLAN. So let's go to the switch 1, switch 2, and switch 3, console them. Switch 1, this is my switch 1. And then we have the switch 2, as well as my switch 3. So the first step, we need to create the VLANs. So let's go to the switch 3 here. We'll change the host name so that it will be easy for us to access. So we'll create a VLAN 10, VLAN 20, VLAN 30, and the VLAN 40. So I'll be using 4 VLANs for testing out. And likewise, the show history command might not support here. I can see the show history command, so I can copy these configurations because I'm going to copy paste the same configurations on my other devices, which will be making easier for me. So I can just go and create VLANs here. And the next thing, we'll also try to assign the port. So the VLANs are created, and then I'm going to say G1 by 0. I'm going to say switch port mode access, switch port access VLAN 10. And I'm going to assign G1 by 1 is going to be in the VLAN 20. The access ports which are connecting to the other side. So G1 by 2, switch port mode access, switch port access VLAN 30. So you're going to add 3 hosts for testing out in 4 different VLANs, 4 hosts, 4 different VLANs. So VLAN 30, VLAN 40, switch port mode access. Okay. So this configuration is on the switch side, and additionally, I have to configure the trunk links. So the links connecting between G0/1-2, those are links are the trunk link. So I'm going to say switch port trunk encapsulation .1 to switch port mode trunk. So we have to give this command switch port mode trunk. These are the common commands. The trunk link commands we have to enable. There's a configuration on the switch 3. So the switch 3 side, mostly it is more like an access switch which has the VLAN configurations. If you verify, we do have the VLAN configurations and then the trunk configurations, the access port configurations, mostly you will have that. Okay. So later on, we also configure the gateways, but as of now, we'll stick to this one. Okay. That's the next thing on the switch 3. Now moving on to the switch 1 and switch 2. Now the switch 1 and switch 2 side. Let's go back to the switch 2. First, we'll start with the switch 1. Switch 1 here. Okay. Now the switch 1, we'll change the host name as the switch 1. Now the first thing, again, we have to create the VLANs here as well, because you must have the VLANs created in all the switches, even though you don't have any ports, or else the SVI interface will be down. So we create the VLANs and we need to enable the trunking for the interfaces which are connecting to the other switches. So I'm going to configure interface range G0/1, comma G1/0. So G1/0 is the interface which is connecting the other side. So we need to simply say switch port trunk encapsulation .12 and save the configurations. Okay, so this is something what we have to do. Create the VLANs, assign, configure the trunk links. As there are no access ports, we don't need to configure any of the access ports. Okay, we need to configure the gateways. We'll come back to that. The first, we'll try to finish off the similar configurations on the switch 2 as well. Now, on the switch 2 also, we need to create the VLANs. Make sure that the VLANs are created, even though you don't assign the ports. And make sure that you also configure the trunk. Host name will change to switch 2, and then interface range G1/0, comma G0/2. So these two ports, we have to configure them as a trunk ports. And in terms of verification, if I say show interface trunk, we should be able to see the trunk ports connecting to the other side. So configure the VLANs and assign the ports not required trunk links. We are done. Okay. Now the next part, we also need to assign the IP address. So the next part, once we are done with this part and this part, so the next part is we'll go to the switch 1 and switch 2 will assign the IP address and the default routes as required, because we need to have the default routes pointing towards the ISP. That's something what we have to do. And of course, we need to assign the IP address to the gateway as well. So the gateway address, I'll be using 192.168.1.2.4. We'll assign the IP address to the gateways as well. So we'll go to the switch 1 first. And on the switch 1, the interface which is connecting to the router 2 is this one. So I'm going to assign the IP address as, it's not going to take the IP. The reason is it's a layer 2 port. Now, again, back to the switching. As this port, typically it's a layer 2. Layer 2 means it only works with the switching. If you want to convert this port as a layer 3 to accept the IP address, we have to use the command called no switch port. So no switch port command is going to convert any switch port to a router port, because this port is connecting to the router and we need to assign the IP address. So by default, you cannot assign the IP on the layer 2 port. So we need to give no switch port and then we say IP address. The IP address is 1.1.1.1 with the default subnet mask, which I'm using. And most likely, if the connectivity is perfect, I must be able to reach out the router 2. You should be able to reach out the router 2 IP. That confirms that the connectivity between the switch 1 and the router 2 is perfect. Now, likewise, I need to do the same thing on the There's no other L3 interface. So the next thing, I need to go back and configure the default route. Okay, so I'll also configure the default route saying that 000000. I'll not configure the LAN. The LAN part I'll configure along with the HSRP. Okay, I'm going to stick to that. So we'll simply say IP route 0000 1.1.1.2. That's a default route, which is going to point to the next hop. And the same thing, we need to do it on the switch 2 as well. On the switch 2 side also, we'll go and say interface G0 by 0. We need to set no switch port to change the port into layer 3 and then use the IP address as 2.2.2.2 with a default subnet mask and give no shutdown command to make the interface up. Mostly it is up because the layer 2 port. So also try to ping to the opposite interface IP. We must be getting a reply. Once we confirm that, we need to configure the default route pointing towards the next hop, so that any unknown traffic will be sent to the next hop. So we are done with the WAN configuration. So the WAN interface and the default routes are configured on the switch 1 and switch 2. This will ensure that now based on this, if I try to ping to 12.001, I must be getting a reply. You can see I'm getting a reply. And the reason I'm getting a reply because when I try to ping from here 12.001, based on the default route, it will route the packet to the router 2. Now the router 2 will send it to that particular IP and it will send back, as this router knows these networks directly, so the reply will come. But if you try to ping from here, it will not work because we need to have the reverse routing. We'll see that part once we do. Okay, so basically here we need to configure the NAT also for that. Okay, so this is the next part. We did this configurations. Now the fourth part we need to do is we also need to configure the LAN interfaces. So what we'll do is we'll also add the LAN interfaces. The LAN we are going to configure. So in my case, I'm going to use 4 different VLANs. The 192.168 1 dot network, 2 dot network, 3 dot network, and 4 dot network. So I'm going to give the SVI interface as an IP as 100 here, 100 here, and 101 here. So these are the 2 IPs I'm using. So they're all 1 dot network, 2 dot network, 3 dot network, and 4 dot network. So the next thing, we need to configure the SVI interfaces, which will be the physical gateways for all the users for all the 4 VLANs. Okay, and after that we need to configure the NAT. That also comes part of the prerequisite as well. So if you see, most of the time, you see these configurations are already there, but I'm trying to show you everything so that you understand how the things goes in the real networks. So the next thing, we need to create a VLAN. On the VLAN, I'm going to assign the IP address as 192.168.1.100. That is going to be my primary gateway. 255.255.255.0. That's my primary gateway. Okay, and no shutdown command is not required. So in terms of configuration, this is my primary gateway, and then we'll say secondary gateway. Like that, we'll create 4 different VLANs. I'll change the things here. It makes easy for us to copy paste. And the VLAN 30 will be using 192.168.3 dot subnet, and the VLAN 4 will be using 192.168.4 dot subnet. So these are the physical gateways which I'm trying to configure. No shutdown command is not required because they are the SVI interfaces. By default, it will be up and running. So if you say show IP interface brief, you can see the SVIs are down. I think I need to add the no shutdown command here. Okay, just check this thing because normally I don't think that's required in the real switches. Mostly the SVIs will be up and running, but still we'll try to add this no shutdown command and quickly say show IP interface brief. To verify the SVI interfaces, you can see the SVIs are up and running. Okay, that's the first thing. And the same thing, we need to do it on the switch 2. So if you go to the switch 2 side, on the switch 2 side, we need to just change the gateway. 101, I'll keep it, not 200. 101 will be good enough. So we'll say 101. The same subnet. Now this is on the switch 2. So on the switch 2, we'll give these configurations. So where is my switch 2? Now this is my switch 2. We go to the config mode. Okay. So if the VLANs and the trunks are running perfect, then what I should see is I must be able to reach out the other gateway. That's what I'm expecting. You can see I'm able to reach out the other gateways like 2.100. From switch 2, I should be able to ping to the other gateways. If VLANs and trunking configurations are perfect, you will be able to see that. Okay. That confirms that your VLAN and the trunk configurations are running fine. And again, as I said, STP has nothing to do with here because STP is a different concept. STP runs separately. So it will ensure that there's no loops and other things that will take care. Okay. So as of now, both the SVIs are able to ping with each other with 192.168.1.subnet. Okay. Now the LAN part is done. Now the next part is, now what I want is, I want to do the configuration. Of course, I'll also configure the end host. Let's configure the end host as well. Now the end host is also something we have to do it. Now the end host needs to assign the IP address. So I'm going to assign the IP address as 192.168.1.1, 2.1, 3.1, and 4.1 as per the subnets. And the gateway address, I'm going to assign the virtual gateway. So I'm going to create a virtual gateway will be for each. I need to assign the virtual gateway. So the physical gateway is 192.168.100, 101. Now we can decide the virtual gateway. I'm going to use 150. Okay, 150 for all. So that will be the virtual gateway. So we'll try to quickly do that on the end host, the virtual gateway. As of now, we need to go back to my host. We'll also start these 4 devices. And for each device, I need to assign the virtual gateway. So the switch side configurations are done. I think I can just export this so that these configurations are saved. And we'll go to this one. Now the first host will be in the VLAN 10. So the first host will be in the VLAN 10 and the IP address is going to be 192.168.1.1. So this is my host name as a router 1 in the VLAN 10. And the IP address is going to be 0 by 0. What is the interface connecting this side? I think it's F0 by 0. So the F0 by 0 interface will assign the IP address as 192.168.1.1 using, and then no IP routing. We'll disable the IP routing and then we'll say the default gateway. Default gateway is going to be 150. Of course, we can test with the physical gateways if end-to-end is working or not. But as of now, what I'll do is, because that's not going to work unless you do the NAT or reverse routing, or we need to enable the reverse routing. So what I can do is from here, I can add either the static routes for 192.168, 1 dot network, 2 dot network, 3 dot network, and 4 dot network, so that when I initiate the traffic from 1.1, it will reach the gateway and the gateway will forward based on the default route. And then the router 2 will route the packet back with the static routing. It will reach out back to this one. So you can add the static routes on both the sides. Or the other option, we can simply configure the NAT. I'll go with the NAT concept just to test with the NAT because that's how it's going to be in the real scenarios as well. Because these are internal addresses which will be private addresses. So we don't, the service providers will not identify the private addresses. So if you don't want to include the NAT, if you just wanted to make it simple without NAT, you can also do that like we did in the previous scenarios. We'll try to go with these options. So what I'll do is the default gateway, fine. That's my default gateway. But before I move on, I'll just try to confirm whether I have the reachability to my physical gateways. This is very important because if the physical gateways are not reachable, then there might be some VLAN configuration issues. So if we misconfigure the VLANs in that scenario, I think 200 is not there. We did not configure 200. We configured 101, if you remember. Okay. So just remember these addresses. So we need to say 101. That is my another gateway, the second gateway. So this is very important. When you're able to ping to the physical gateways, then most likely if the HSRP configurations are correct, then you will also be able to work with virtual gateways as well. Okay, so let's move to the router, the next device, the second device in the VLAN end host. Yeah, I think this one. So this is my VPC. VPC is slightly different. We configure how this comes. So the VPC, I think this is a VPC what I'm using. The IP, we give like this IP, and the IP is from 192.168.2.subnet, and the gateway address is 2.150. As of now, this takes, and if you try to ping to the physical gateways 2.100, I must be getting a reply, and also 101, I must be getting a reply. So this confirms that the VLAN configurations are perfect, because if you assign this port in a wrong VLAN, if it is not in the VLAN, then you will not be able to see the communication happens. Okay, so most of the troubleshootings you do because of the misconfigurations. So make sure that you configure everything correctly. So if you know the correct configs, it's easy to troubleshoot. Now the third device is going to be 192.168.3.1, which is going to be using 3.150 as my gateway, which is the virtual gateway. I should not give IP address because this is a command which just gives IP. And then I'll try to ping to my physical gateways just to confirm my physical gateways are running fine. I'm getting a reply. Also 101, I must be getting a reply. This confirms that your gateways are working. The physical gateways are working. Later on, HSRP, once it is done, I should be able to reach the internet as well. Now, moving on to the last one, the same way I have to do the last one. You can just add the routers or VPCs. I'm just mixing these things because I want you to use whichever easier option. IP address is 192.168.4.1. This is for 4.subnet. And then the gateway address is going to be 4.150. That's a virtual IP. Again, I'm using IP address. It should be IP. Because normally in the routers, this is the command. So we'll try to check the reachability to my physical gateways, which is 4.100. I must be getting a reply. And likewise, 101, which is the second gateway, that is also working, which means the SVIs, VLANs, trunks, the entire configuration is perfect. Now, this will confirm that your gateways and the LAN is perfectly configured. And we already tested the WAN connections also working fine. Now we need to make sure that we are able to reach out from here to the internet route. So for that, we need to do two things. One is we need to configure the NAT to translate these addresses. And the second thing, we need to configure the HSRP. So two things. We'll finish with the NAT first, and HSRP will do it separately. First, I'll try to finish with the NAT. So what we'll do is we'll try to go and see the NAT configuration. Now, coming back to the NAT configurations, we have to configure the NAT on both the switch 1 and the switch 2. So how we configure the NAT? We have to write an access list, standard, LAN, right? That's for LAN 1, let's say. And what is my LAN network? We need to say permit. I'm using 192.168.1.subnet, and I'm using 192.168.2.subnet, and I'm using 192.168.3.subnet and 192.168.4.subnet. Now, the same thing we need to do it on the switch 2. I'll do in parallel so that we don't miss any of the steps. We'll go to the switch 2 and I'll do the same thing on the switch 2 as well. Now, the switch 2, we can also write access list standard, let's say LAN 1. We can just combine all the networks and I can write in single line. So we can just say 0.0.255.255, which means technically all the networks, whichever starts with 192.168 will be included in that. I hope you know this from the basic ACLs. It matches the first two portions. We can just write in one line also. This is another way. Write the ACL. Now the second step, we need to configure. The next step will be, we have to say IP NAT. The next step will be configuring the NAT here. Okay, so in terms of NAT configurations, we have to say IP NAT inside source list. The list is LAN 1. And then we have to say interface. Now, what is the interface connecting to the ISP? That's my G0 by 0 interface. And I have to say overload. That's the NAT configuration. Okay. And likewise, I need to do the same thing here as well. So I think I can copy paste the same because it's the same interface I'm using on the other side as well. So I can copy paste this, which is going to translate that. And then we need to tell what is my inside and outside interfaces. Now, what are my inside interfaces? Interface VLAN. So all the users will be coming from VLAN 10, VLAN 20, interface VLAN 20. That is also my inside. And VLAN 30, that is also my inside. And the VLAN 40, that is also my inside. And the interface G0 by 0, that is my outside interface. Now, the inside is nothing but the interface from where you get the private IPs, the outside interface from where you get the public IPs. You can see this is the complete configuration I have to do. The same thing on the switch 2 as well. I had to go to switch 2 and do the same thing. Okay, IP NAT inside and outside configurations. Once we are done with this, so now the NAT configurations, I hope I'm done with all the things. Let's quickly confirm this. Now, to confirm, we need to go back to any one of the host or the device and test by initiating some traffic. Okay. But again, we have given the gateway as the virtual gateway. If you see show IP route static or show IP route. As of now, the virtual gateway is not configured. So what I'll do is I'll simply change the gateway to the physical gateways and I'll try to test the reachability, because that's how we have to confirm before starting the HSRP configurations. Because your existing physical gateway should be working fine end to end with all the routing and everything. That basically confirms that. Okay. Then only we'll be able to reach out. So I'll try to change the gateway and we'll try to verify. The same thing, you can do it on other devices as well. So first I'll go to the config mode. I'll say the default gateway is the physical gateway 1.100. And then I'll try to ping to 12.0.0.1, expecting a reply. If not reply is not coming up, then I just need to see the routing related issues or maybe the NAT translation. These things we have to check. Okay, so now as per the previous configurations, what we did, we actually configured the NAT on these devices, expecting that all my private networks will be translated with this public IP. So the problem is we have seen that the reachability issues was there. If we just quickly go and check, we were not able to communicate. That was the problem. Even though I have changed the gateways when I was trying to ping, that was not working. So what I did, I tried with a different NAT. Let me just quickly show you that part as well. So what I did, I just removed the NAT configurations because I was using the exit interface to do that. So what I did, I just removed the exit interface and I tried to use the public IP. So if you see the configuration here, I verified the ACL, everything is perfect. Now what I did, I created few things like I want to translate this 192.168 1 dot network, 2 dot network, 3 dot network with the public IP, let's say 5111. And then on the router 2, I try to add a static route for the public IP, assuming that, there might be some routing related issues, because if you see there's no reverse routing or whatever the routing related issues, because I'm expecting this 192.168.1.1 when it is trying to reach 12.0.0.1, it reaches the gateway and then it's going to translate this 1.1 with the public IP exit interface or 5111 if I'm using this configuration, another IP, with the destination address 12.0.0.1, which is the internet, and reaches the router 2, and the router 2 knows exactly how to reverse back to 1.1.1.1 or 5111 based on the static route, and it should come back and it should reach. So this works with a router. If you test the same thing with the routers, normally it works, but here, as the multi-layer switches might not have the same functionality with the NAT, and that might be the reason. So typically in the production networks, you will be configuring the NAT on the routers or on the firewall. So you will have one more device as the exit device, which will be connected, and that will be doing the NAT. So right now, what I'm doing, I'm going to skip the NAT part and we'll keep it simple without the NAT so that we can work. Or else, I need to add one more router which will be doing the NAT and, maybe the firewall or maybe the router and then do the NAT. As this lab is not more focused on the NAT, so we'll try to skip that and we'll keep it simple. Okay, that's what I decided to test it out this one. So we'll go to the switch one. On the switch one, I removed the NAT configurations and I tested out. So probably I tried this NAT and then I removed the NAT as well, the NAT which I configured, because that was also not working. So what I did, I removed the NAT. Let's remove the same thing on the switch 2 as well. And we'll stick to the simple without any NAT configurations. So what I'll do, I'll simply remove this NAT. Anyway, on the interfaces, once I remove the NAT, I can also remove this configuration, but that's fine. We don't need that. So we'll simply skip this one. And let's quickly confirm if I still have any NAT configurations. So I do have the NAT on the interfaces, but that's fine because as we remove the main global configurations, the main global configurations has been removed. So this is not going to impact. So if I want, I can just go ahead and remove, but not required. So which means now when I send the traffic from the source address 192.168.1.1, as the packet goes to the gateway, whenever I send the packet to 12.0.0.1, I'm expecting this should go to the gateway. And the gateway should have the default route, which is going to send it back to the router 2. And if you remember, we already have that one. We already configured that, which means the packet goes to the router 2 and the router 2 is supposed to send back to this one. So for that, there must be a static route for this network, not only 1 dot network, 2 dot, 3 dot, 4 dot. So I can just summarize all this in one network like SAC16, which tells that, anything matches with 192.168. So what I'll do is I'll go to router 2 for the reverse routing to make sure that I'm going to add a static route for both. So we are adding a static route saying that if any packets come from 1 dot network, send it to 1.1.1.1, 2.2.2.2. So the end result will be, if I go back again to my host, I must be able to reach out. So if you see the trace 12.0.0.1, I'm able to reach out from the gateway because I have configured the physical gateway as 192.168.1.100. That's what I'm expecting. The packet should route, or the trace should show me that one. Let's quickly check that, because before I go ahead and configure the HSRP, I need to test this, because as you can see here, this is my first PC. So you can test with any one VLAN, that's fine. If you want to test with all the VLANs, you can still do it. As of now, if you see the gateway is the physical gateway. So I'll change the gateway and quickly check the second gateway also, which should be working, 101. And if I try to reach out 12.0.0.1, the second gateway also should be working. That's going to work. Okay, okay, so as of now, what I'll do, we'll change the gateway because our main lab is based on the virtual gateway. So we'll change the virtual gateway right now to this one. And we'll try to ping to the 12.0.0.1. The ping will not work unless and until you configure the HSRP. Now, same way, if you want to test with another virtual PC, we can also do that. If you just wanted to change here as well, let's say the VPC is on 2.1 host, that is on 2. Subnet. I'll assign the physical gateway first, and we'll try to test with reaching out the internet routes, assuming the end-to-end routing is perfect. And likewise, now what I'll do is I'll change the gateway as 101 and I'll again test it out just to confirm that the second gateway is also working. For a more verification, we can use trace 12.0.0.1. We can see the trace shows up. So same way you can test with the VLAN 30, the VLAN 40. But now what I'll do is I'll change back to the virtual gateway. The virtual gateway is, the IP address is 192.168.2.1. and then the gateway is 192.168.2.150. 150 is the virtual IP. Now, once I give the virtual IP, it's not going to work because still we did not configure the HSRP. So once I finish up the configuration with HSRP, we should see the communication should start. Okay. Same thing with the other host. You can also go and test the same thing. So this is all the prerequisite setup. As I said, the NAT is not going to work in this case because of some limitations. So as the NAT is not the main lab, what we are going to test. So probably now we have the prerequisite lab ready to test and configure the HSRP configurations with VLANs on switch 1 and switch 2.